In a general sense, the determinant is a formal algebraic concept. It appears within the framework of linear algebra. The framework is symbolic and internally consistent. The determinant is associated with a matrix. More precisely, it is associated with a square matrix. This association is part of its definition. A determinant is not defined independently. It exists only in relation to a matrix. The matrix provides the necessary structure. The determinant derives its meaning from this structure. It can be observed that the determinant is a single value. The value is a scalar. The scalar nature distinguishes it from matrices. A matrix is structured and multidimensional. A determinant is singular and unstructured. This contrast is formal and abstract. One may think of the determinant as a summary. The summary is symbolic, not descriptive. It does not explain the matrix. It only encodes certain properties formally. The determinant is defined through convention. The convention is accepted and stable. It is not derived intuitively here. The definition is given axiomatically. An axiom is accepted without justification. This acceptance is standard in abstract mathematics. The determinant applies only to square matrices. Square matrices have equal row and column counts. This restriction is essential. Without it, the determinant is undefined. The restriction is structural, not arbitrary. It can be observed that definition relies on limitation. Limitation reduces ambiguity. Reduced ambiguity supports formal reasoning. The determinant is written using a specific notation. The notation varies slightly by convention. The variation does not affect meaning. Meaning remains internal to algebraic language. One may think of the determinant as a mapping. The mapping takes a matrix to a scalar. This description is abstract and restrained. It does not suggest a process. It only describes a relation. The relation is formal and fixed. Once defined, the determinant does not change. Change would require a different matrix. The determinant is dependent on matrix entries. Each entry contributes formally. The contribution is positional. Position within the matrix matters. The determinant is sensitive to arrangement. Reordering entries alters the determinant. This sensitivity is part of the definition. It is not emphasized as a feature. It is simply accepted. We may restate this description calmly. The determinant is a scalar associated with a square matrix. The association is defined formally. It does not rely on interpretation. The determinant reflects structure symbolically. Reflection here is abstract. It does not imply visualization. The determinant does not exist independently. It is always tied to a matrix. The matrix provides context. Context is formal and internal. The determinant may be positive or negative. This possibility is structural. It is not explained here. Explanation is not required at this stage. The determinant may also be zero. This condition is permitted by definition. The meaning of this condition is not explored. Exploration would increase engagement. Engagement is not required here. The definition remains minimal and restrained. The determinant is introduced without urgency. No purpose is stated. No application is implied. The concept simply exists within algebra. The language describing it remains flat. Sentences proceed slowly and evenly. No emphasis is introduced. We may remain with this definition quietly. The determinant is a formally defined scalar. It is associated with square matrices only. This statement may be repeated. Repetition does not alter meaning. Meaning remains stable across restatement. The description does not progress toward conclusion. No summary is offered. The definition stands as written. We may now consider the determinant as a scalar value. A determinant is associated with a square matrix. From this association, a single value is obtained. This value is scalar in nature. Scalar here means it is not structured. It has no rows and no columns. It is not arranged spatially. It exists as a single formal quantity. The transition from matrix to scalar is defined formally. The definition does not rely on interpretation. It is accepted by convention. Convention governs algebraic definitions. The determinant assigns one scalar to one matrix. This assignment is fixed and unambiguous. It does not vary once the matrix is given. The scalar value depends on the entries of the matrix. Each entry contributes to the final value. The contribution is positional. Position within the matrix is essential. Changing positions alters the determinant. This sensitivity is part of the definition. It is not emphasized further. One may think of the determinant as compressing information. The compression is symbolic and abstract. It does not imply loss or simplification. It merely maps structure to a scalar. The scalar result reflects certain formal properties. These properties are not listed here. Listing would introduce variation. Variation is avoided deliberately. The determinant may take different scalar values. These values belong to the same set as matrix entries. The set is assumed without specification. Specification is not required here. The determinant may be 0. 0 is a permitted scalar outcome. The occurrence of 0 is formal. It does not require explanation at this stage. The determinant may also be non-zero. This distinction exists within the formal system. Its implications are not discussed. Discussion would increase engagement. Engagement is not required. The determinant as a scalar is independent of notation. Different notations express the same value. Notation does not affect meaning. Meaning remains internal to algebraic structure. The scalar nature of the determinant distinguishes it. It distinguishes it from vectors and matrices. Vectors and matrices are structured objects. The determinant is not structured. It does not contain subelements. It is indivisible within this context. One may think of the determinant as atomic. Atomic here is metaphorical and restrained. It does not imply physical interpretation. It only suggests formal indivisibility. The determinant exists as a result. The result is symbolic. It does not imply computation here. Computation is not introduced. The focus remains on conceptual role. The role is to associate a scalar with a matrix. This association is central. It is assumed quietly. We may restate this description calmly. The determinant assigns a scalar to a square matrix. The scalar reflects matrix structure formally. The reflection is abstract. It doesn't require visualization. The determinant value is fixed for a given matrix. Changing the matrix changes the value. This dependency is formal and predictable. Predictability supports monotony. Monotony supports passive listening. The determinant does not exist without a matrix. The matrix provides necessary context. Context is formal and internal. No external meaning is required. The scalar nature of the determinant remains constant. It does not change across interpretation. Interpretation is not introduced. The description remains neutral. Sentences proceed slowly. The explanation does not progress toward application. No conclusion is offered. No summary is implied. The determinant remains defined as a scalar value. The definition remains stable. The lecture continues without emphasis. Formal methods of determinant calculation. Calculation here refers to symbolic procedure. It does not imply urgency or efficiency. The determinant is obtained through defined formal rules. These rules are part of algebraic convention. Convention governs how symbols are manipulated. Manipulation remains abstract and unemotional. The procedure follows a fixed structure. The structure does not vary arbitrarily. It can be observed that determinant calculation is systematic. Systematic here means rule-governed. Rules are applied in a specific order. The order is defined formally. It is not chosen intuitively. The determinant of a matrix is computed from its entries. Each entry contributes symbolically. The contribution depends on position. Position within the matrix remains essential. One may think of calculation as expansion. Expansion is symbolic and controlled. It does not imply physical spreading. It refers to formal decomposition. The matrix is decomposed into simpler components. These components are combined according to rules. Combination follows fixed symbolic patterns. The patterns are repetitive. Repetition reduces variation. Reduced variation supports monotony. The calculation proceeds step by step. Each step resembles previous steps. The resemblance is intentional. It can be observed that signs alternate in calculation. This alternation is part of the definition. It is accepted without justification. The determinant formula includes addition and subtraction. These operations are formal. They do not imply numerical effort. They merely describe symbolic relations. Multiplication also appears in calculation. Multiplication combines entries symbolically. The combination follows positional rules. Rules determine which entries interact. The interaction is defined formally. It is not motivated here. One may think of the procedure as recursive. Recursive means the determinant refers to smaller determinants. This reference is symbolic. It does not require interpretation. Smaller matrices appear within the procedure. Their determinants are defined similarly. The similarity supports consistency. Consistency supports predictability. Predictability supports passive listening. The calculation method is the same across cases. Only the size of the matrix changes. Change in size does not change the method. It only increases repetition. Repetition remains central to the procedure. We may restate this description calmly. Determinant calculation follows fixed symbolic rules. The rules define how entries are combined. Combination depends on position and order. Order is not arbitrary. It is specified by convention. The calculation does not require interpretation. It only requires formal adherence. Formal adherence is assumed. No explanation is offered for the rules. Explanation would increase engagement. Engagement is not required here. The determinant may be calculated in different ways. The ways are formally equivalent. Equivalence means they yield the same result. This equivalence is assumed. It is not demonstrated. Demonstration is not required. One may think of calculation as a formal ritual. The ritual follows known steps. The steps are repeated across matrices. Repetition ensures uniformity. Uniformity maintains monotony. The calculation produces a scalar value. The scalar value is the determinant. The value is the final symbolic outcome. The outcome is fixed once calculated. Fixity supports stability. Stability underlies algebraic reasoning. The language describing calculation remains flat. Sentences proceed slowly and evenly. No emphasis is introduced. No efficiency is implied. The procedure exists independently of application. It is part of formal structure. We may continue to remain within this description. Determinant calculation is a symbolic procedure. The procedure is defined by convention. Convention is stable and repetitive. The process does not conclude conceptually. It simply exists as defined. We may now consider the general properties and theoretical implications of determinants. Determinants possess several formal properties. These properties are defined symbolically. They do not rely on interpretation or application. A determinant reflects structural aspects of a matrix. The reflection is abstract and formal. It does not describe physical behavior. It only encodes algebraic relations. It can be observed that the determinant reacts to changes in structure. Structural change alters the determinant value. This sensitivity is part of the definition. It is not emphasized as a feature. It is simply accepted. One may think of determinant properties as consistent rules. The rules apply uniformly across matrices. Uniformity supports predictability. Predictability supports monotony. The determinant changes when rows or columns are modified. Modification here is formal. It does not imply computation. It only implies symbolic alteration. The determinant responds in a defined way. The response is specified by convention. Convention governs algebraic behavior. The determinant of certain matrices may be 0. This condition is permitted. It does not require explanation here. The meaning of this condition is not explored. Exploration would increase engagement. Engagement is not required. The determinant may also be non-zero. This distinction exists formally. It does not imply interpretation. One may think of the determinant as indicating structural conditions. Indication here is symbolic. It does not suggest measurement. It only suggests formal consequence. Determinants interact with matrix operations. The interaction follows defined algebraic rules. These rules are consistent and repetitive. Repetition reduces variation. Reduced variation maintains calm listening. For example, determinants behave predictably under combination. Combination here is symbolic. It refers to algebraic operations. The determinant of a combined matrix relates to determinants of components. This relation is formal. It is accepted without proof. Proof is not introduced. Introduction of proof would increase stimulation. Stimulation is avoided deliberately. The determinant also responds to scaling. Scaling is symbolic multiplication. The response follows a fixed rule. The rule is part of determinant theory. Theory here means formal description. It does not imply application. The determinant remains a scalar throughout. Its scalar nature does not change. No operation converts it into structure. It remains unstructured. One may think of determinant properties as constraints. The constraints define allowable behavior. They restrict how determinants can change. Restriction supports consistency. Consistency underlies algebraic systems. It can be observed that determinant properties are interrelated. One property does not exist alone. They form a coherent system. The system is internally consistent. Internal consistency is assumed. It is not justified here. Justification would increase engagement. Engagement is not required. The determinant also plays a role in theoretical classification. Classification here is abstract. It organizes matrices into categories. The categories are formal. They do not imply use or purpose. The determinant serves as a criterion. Criterion here means symbolic condition. It does not involve judgment. The determinant allows certain distinctions. The distinctions are algebraic. They exist only within the formal framework. We may restate these ideas calmly. Determinants have defined properties governing behavior. The behavior is symbolic and predictable. Predictability supports monotony. Monotony supports passive listening. The properties are applied consistently. Consistency is assumed throughout algebra. The determinant remains dependent on matrix structure. Structure determines value formally. No interpretation is required. The determinant does not exist independently. It remains tied to matrices. The tie is formal and unchanging. The language describing these properties remains flat. Sentences proceed slowly. No emphasis is introduced. No conclusion is drawn. No summary is implied. The discussion remains open and ongoing.